Introduction to electrical and electronic circuit symbols. So first of all, we're going to go over the basic purpose of electrical and electronic circuit symbols, and then we'll look at some detailed examples. These are graphical symbols which convey precisely how component parts are connected together to perform an electrical or electronic function. These component parts can consist of electricity sources, such as batteries or power supplies, wires, switches, and electronic components, such as resistors, transistors, and integrated circuit chips. These may also include test and measuring devices, such as meters and displays. There are hundreds of symbols, all of which comprise this universal graphical language. This language has developed and evolved over many years as new symbols have been added. Sometimes there are several symbols which convey the same function or device, and these can be used interchangeably. Each of these symbols either communicates its own function in the circuit or how it contributes towards the overall circuit's function. This gives the designer or the engineer an idea of how the overall circuit is supposed to work. You will see many examples of this as this channel develops. We will touch on a few examples in this introduction, and we will come to these shortly. But what do we mean by a circuit? A circuit consists of a number of electrical and electronic parts or components which are joined together in a well-designed manner to complete a closed circle or loop, such that electricity flows out from one end, the positive terminal, and into the other end, the negative terminal. If the electricity cannot find a way to complete this circle, then the circuit will not work. Bear this in mind at all times. Sometimes we introduce an electrical component into the circuit which deliberately breaks this circuit. This is called a switch. You will also become familiar with this theme as it is used everywhere. It is done electrically, that is mechanically, and electronically with transistors and IC chips. We now understand the basic idea of a circuit. When drawn with symbols, either on paper or on a computer, it is called a circuit diagram. Another name for this is schematic diagram. These two terms are often used interchangeably, but more often a schematic diagram includes detailed component values used in an actual built or practical circuit. Circuit symbols thus allow us to design comprehensive, that means easy to understand, electronic circuits, even if they are complex. This means we can document electronic designs in a consistent and understandable way, which means other electronics specialists can read and understand those designs. This is particularly useful when we're designing a circuit using integrated circuits. We don't necessarily need to know how an IC chip works inside. All we need to know is how it works from our outside view of it. Circuit symbols in schematic diagrams help us when we are troubleshooting problems, whether that's with products we have that have gone faulty or in designs we have made ourselves and documented. Sometimes you can get hold of schematic diagrams for products that are many years old, and these will help us to identify potential problems or possible parts of the circuit where a fault may be located, and then carry out a repair, and perhaps identify why the circuit developed the fault. Lastly, I need to mention orientation and conventions. Some components are drawn in a specific way in order for them to be easily recognizable and understood. This also applies to some circuit building blocks, such as we will see with the 555 timer chip and with operational amplifiers or op-amps. These conventions help you to recognize circuits and their functions. Many of these conventions typically come from component manufacturers, as shown in their datasheets. We will look at examples of these in future videos. Typically, schematic diagrams are drawn from left to right, as is component function and progression. This is directly at odds with many of those poor quality dead bug LED chaser circuits you see on YouTube channels, where the circuit diagrams, if provided, are not drawn to any kind of standard at all, making those designs not very reproducible. There are thousands of circuit and component symbols. You don't have to learn them all. You will learn the ones that you need as you progress. You'll recognize when you need to learn and use a new symbol and learn to look it up from various sources. The basis for symbols comes from British Standards BS 3939 and its derivatives, and I have a copy of it here. Some other sources include Wikipedia, and I've got this website here, conceptdraw.com. I'm not promoting the product, it's just the impressive list of symbols that it has on its webpage. Let us now look at some basic symbols. Connection, or wire connection, also known as a node or a conductor. Earth connections, battery supplies and voltage sources, AC and DC and polarity, variability, fuses, switches and relays, resistors, capacitors, diodes and light-emitting diodes, transistors, operational amplifiers or op-amps, logic gates, and the 555 timer chip. So we'll take a look at these in a little bit of detail, and we'll look at these in more detail in later videos. We begin with conductors and connections. We need to spend a few moments on carefully considering this. The first item then is a wire, which is simply represented by a line. And here you can see the equivalent real-life example of a piece of wire with the metal ends exposed, and the majority of its length is this red plastic insulation. A wire is used to join or connect two components together. In a circuit or schematic diagram, what happens when you have two wires crossing over each other? If they are not connected to each other, you draw them crossing over. And here you can see what that looks like in real life with red and black insulated wires. However, this symbol can be tricky to interpret, particularly in CAD layouts, because sometimes it can mean they are connected. If hand-drawn, the alternative symbol may be better, and is one which I prefer. The next symbol is when you have a junction of two conductors and they are joined together. Note the large dot at the junction. In practice, you can see here I've joined a green and a blue wire together by twisting the conductor ends together to make the electrical connection or junction. And similarly, several wires can join several components together. Note also that other methods of joining together components include terminals and circuit board tracks, and many other methods. We'll look at these in a separate video. The important thing to remember, though, is that the electrical joining of two or more components together with a conductor is called a node or node point. This will become quite an important aspect to remember when it comes to layout design. The earth connection symbol indicates that the circuit is connected in some way to the physical ground, usually through the mains electricity supply. Related to this is the chassis connection. This is when a connection is made from the electronic circuit to a metal case or frame, though this case or frame may not necessarily be connected to earth as well. Next we have power sources, and we start with a single cell. If we're talking about portable zinc alkaline cells, these are usually 1.5 volts. And if we're talking about lead acid cells, these are typically 2.0 volts. Next, if we have several cells together, we draw the two end cells and a dotted line between them. This represents a battery of cells, and this is where the term battery comes from. An alternative is to specifically draw all the cells which make up the battery. Batteries are okay for portable devices, but more substantial circuits require different types of sources. These are usually mains-based power supplies. Bench power supplies offer an easy means to provide power to a test circuit while in development, while a more permanent power supply circuit can power a final product. Sometimes the power rails are simply drawn with just the voltage showing, coming from a dot, to simplify the schematic diagram. Polarity symbols indicate the orientation of the voltage. Conventional current flows from positive voltage to negative voltage. Put another way, conventional current always flows from a higher voltage potential to a lower voltage potential. This is very much like atmospheric air pressure or water pressure. Winds always blow from high to low. There are different types of electricity. We are familiar with DC, which stands for direct current, which is when electricity flows only one way, from positive to negative, such as you get with batteries. We are also familiar with AC, or alternating current, which is what mains electricity is. This is a sine wave shape, and its polarity changes quite quickly, such as 50 or 60 times per second. Variability symbols indicate if a component is of a variable or preset variable type. Watch out for these symbols, particularly with resistors and capacitors. A fuse symbol is simply a rectangle box with a line going through it. This is the first of the components that visually looks exactly how it is made. It is simply a fine wire which is designed to vaporize when a current above a certain level flows through it. The alternative symbol conveys the idea of a weak point at the center where it will break. Fuses and switches are the first electrical components we need to learn. They provide electrical or electromechanical control of electricity. The simplest electrical switch is a normally open contact switch. There are dozens of different configurations on this theme. Likewise for normally closed contact. Electromechanical relays are similar to switches in that they have switch contacts, but they work by providing a voltage to a coil which produces a small electromagnet which activates the switch. We'll be playing with relays in another video. Resistors have two general, well-known symbols, a rectangle and a zigzag. Resistors resist the flow of electricity or electric current. We'll examine these in detail in another video or two. Capacitors store electricity as an electric charge, much in the same way as you might understand static electricity. The symbol represents two metal plates, which is exactly how it is constructed inside, or more precisely, two very thin metal foils rolled up together with an insulator between them. Now we move on to semiconductors, and first let's look at diode symbols. Diodes allow electricity to flow in only one direction. The conventional current flows in the direction of the arrow. The vertical line on the right of the symbol represents a block on current flowing in the opposite direction. Similarly for light-emitting diodes, or LEDs. You can tell the difference between ordinary diodes and light-emitting diodes by the two little arrows on LED symbols. Transistors come in many varieties, but the two basic types are NPN and PNP. They have three legs. From top to bottom on this NPN transistor, these are the collector, the base, and the emitter. The emitter is the one that has the little arrow, and its direction shows the flow of conventional current through it. There are a variety of orientations you can draw transistors, and I've done this with the PNP transistor. We will now take a brief look at integrated circuits, or ICs, and we'll start with operational amplifiers, or op-amps. An op-amp is a high-gain amplifier that measures the difference between two small voltages and magnifies the result to a useful level. Here you can see the symbol functions from left to right, with the inputs on the left and the output on the right. Now let's take a brief look at digital logic gates. Beginning with an inverter, this takes a logic 1 input and outputs a logic 0. And if the input is a logic 0, it will output a logic 1. An OR gate will output a logic 1 only if one or other or both inputs are a logic 1. An AND gate will only output a logic 1 if both inputs are a logic 1. An exclusive OR gate will only output a logic 1 when one of the inputs is a logic 1, but not when both are a logic 1. We will look at logic gates extensively in later videos. Note also how all the gates are drawn going from left to right. Lastly, let's quickly take a look at a 555 timer circuit diagram in a circuit I drew in a computer program about 25 years ago. This circuit is a general circuit using three 555 timers, and these two depict the circuit's function flowing from left to right, with the output of each stage, that is, pin 3, on the right. Of course, we'll be making quite a few projects with 555 timers. I hope you found this introduction to electrical and electronic circuit symbols useful. Please let me know your views on this video in the comments below. Please check out the keyword searches in the description below and feel free to explore looking up circuit symbols on your own. We will be going into more details as we start experimenting and building circuits. Please let me know what experiments and circuits you would like me to cover, and I'll do my best to put them on a to-do list. And if you've enjoyed this video, please click the like button and subscribe to the channel for more content like this coming soon. Thanks for watching, and I'll see you next time.